everyone, welcome to yet another video of electromagnetic fields. In today's video we are going to see about vector fields. So the topic we are going to cover in this particular video is what are the different types of vector fields we have, and then we will see in the upcoming videos what are vector calculus and what are the calculations using a vector, like vector addition, multiplication and subtractions and all. So first, what is a scalar and vector field? Fields are generally classified into two types. One is scalar field, the other one is vector field. Scalar fields, we already know about what is meant by scalar and what is meant by vector. Scalar means those quantities that are characterized by magnitude alone, that are called as scalar. For example, the atmospheric temperature, pressure, the mass, weight. So these are scalar quantities. We used to determine them, we used to address them with their magnitude only. It doesn't have any directions. So scalar are characterized by magnitude only, whereas vector fields are quantities that are characterized by both magnitude and direction. For example, velocity of a wind velocity is a vector field, vector quantity which has both magnitude and directions. For example, if you say the speed of a car, velocity of a car, we used to say it travels at this much kmph at this particular directions. So we can easily address them with their magnitude as well as its direction. Hence these are vector fields. The other example is gravitational force, and we can say n number of vector fields. Examples. Next, vectors, how we represent a vector and what parameters it has. Vectors are represented by arrows. So we used to the top of it we used to put an arrow, which means that it is a vector. So vectors have a magnitude or length and also a direction. So a vector can be expressed in terms of these two properties, either and they are the length of the vector and the other one is the direction. Now we will see unit vector. What is meant by unit vector? So those vector with a magnitude of 1 unit, that is called as unit vectors. So any vector can be expressed as a scalar multiple of its unit vector. So unit vector is denoted by, let the vector be A. The distance between the vector is OA. So if we want to denote the unit vector of that particular rectangle vector, it can be represented by A vector. OA is equal to OA vector divided by modulus of OA. This is the formula for unit vector, where OA vector is the distance between the point O and A, and the denominator OA vector gives the modulus value, which is the magnitude value. Position vectors, as the name implies, it is the position of a particular quantity in a three-dimensional position. For example, if I want to mention the position of a desk in a classroom, it has some distance, like I can give the value in x, y and z axis. Likewise, you can also mention a vector, that is a quantity in a three-dimensional space. Let R be a vector and the position of that particular vector is given by xi vector plus yj plus zk vector. The same is distance vector, as the name implies, distance vector. So it is the point between two vectors. Let P be a vector and Q be another vector. So the distance between these two vectors will be a distance vector, and it is given by PQ vector is equal to Q minus P, which is equal to x2 minus x1 into ax vector plus y2 minus y1 into ay vector plus z2 minus z1 into az vector. When we take the modulus of these distance vector, you will get the magnitude value only. So where x, y, z are the three-dimensional points and